Okay, I can't say the word. Equations, right? Right. So, differential equations are equations involving a mix of variables and derivatives, so y-x and dy with dx. Solving these means getting y in terms of x with no dy over dx. Okay, so let's have a look. Okay, we want to solve this. So dy over dx, that equals, we'll factor the y out, x plus 1. Cool. Let's divide both sides by y. So times that by dy over dx, that equals x plus 1. So the idea here is we're going to integrate that in terms of, I'll make this a little bit bigger, in terms, we're integrating both sides in terms of dx. Now, I don't really, the theory here is they cancel out nicely, and then we just solve there. So the integral of 1 over y, that would be natural log y. And then this one here is a half x squared plus x plus c, technically. Okay. So there we are. So now we want to get y by itself. So we're going to get e to the power. So e to the power of all of this here. So I'll write it as 0.5 x squared plus x plus c. Sorry, y equals that. There. And index laws, so plus plus, so we are multiplying. A little sort of hint given to us would be this c, try and turn it into a constant, if you will. So final answer will be y equals e to the power, I'll put it back to the half x squared plus x multiplied by e to the c, because obviously index laws, they add up. And we can turn this e to the c, we can let that just be a new constant, we'll call it a. So the final answer is a times e to the half x squared plus x. And then you might have more of the question that goes when x is 0, y is something, find a, and that's how you make your equation. So that's the first part there, find the general solution. Okay, let's look at a new question. So find the general solution for 1 plus x squared dy over dx equals x tan y. Okay, so I'm probably going to get the y's to one side and the x's the other side. So let's divide both sides by tan y, and I'll divide both sides by 1 over x squared. So I get the following. 1 over tan y dy over dx equals x over 1 plus x squared. Okay, and 1 over tan, I can rewrite that as cot y multiplied by dy over dx, and that equals the same, x over 1 plus x squared. So again, like, I don't really appreciate the maths here, but I don't really care. I'm not at university, so I'm probably making some people cry here, but it's fine. So we integrate that in terms of dx, and they will cancel out quite nicely. We're going to integrate that in terms of dx. So lovely, we can now play along with this. So cot y, I want the integral of cot y. Let's have a look on the formula book. We got it here. So cot y is natural log sine of y. Lovely. Okay, so now we've got natural log sine of y. It would technically be plus c, but we're going to get that both sides. Okay. Now we want the integral of x over 1 plus x. So I think it's going to be, let me look. If I consider y to be, sorry, if I consider I'm integrating this, how would I do this? 1 over x goes to natural log. Yeah, so y equals natural log 1 plus x squared. So dy over dx is 1 over 1 plus x squared multiplied by the derivative, which is 2x. So you get 2x over 1 plus x squared. What that means is the integral of that equals that. Okay, so we're very close. So we need to get this 2 complete pulled out. Fantastic. Meaning, I'm trying to think now. Let's just go. The integral of this equals natural log 1 plus x squared. So I can divide this by 2 and we've got the answer. Fantastic. Okay, so the answer is a half natural log 1 plus x squared. We can put the plus c in now. Okay. Now, the plus c, we kind of want to get rid of this to clean this up, because you might have to use that later in the question. So I'm going to rewrite it as a half natural log 1 plus x squared. And I'm going to do natural log of k. So I'm just going to introduce a new constant. Okay, so this equals, I'm going to use my laws now. I'm going to bring the half over up here. So it's going to be natural log, and it's going to be the square root of 1 plus x squared. That's bringing my half up here. Plus natural log of k. Now we're plusing them, so they're going to multiply by each other. So I'm going to bring this back down. Natural log sine of y equals natural log k multiplied by 1 plus x squared, square rooted. And now we can just see they match up really nicely. So sine of y equals k multiplied by the root of 1 plus x squared. So final answer, y equals the inverse of sine, but in maths we write it as arc sine k root 1 plus x squared. Fantastic, and there we are. So really nice. Okay. Yeah, I think in the math scheme you can kind of skip this line, but I put it in, it makes me feel a bit better about myself and I know what I'm doing. Okay, let's see what's next. I'm trying to think. Yeah, I think the Dr. Frost tip is this bit here is quite important. Gets it cleaned up a bit. Okay, lovely. Right, Differential, I can't say the word. Anyway, equations of boundary conditions. Let's have a look at it. Right. Dy over dx equals negative 3 brackets y minus 2 all over 2x plus 1. Oh, is it a partial fraction? Fun. Okay. For the save myself time, I'm going to assume you can do partial fractions, and I'm going to copy the answer from my notes. Okay, so let's see. Right, okay, I understand. We want to get this y minus 2 down here, right. So divide both sides by y minus 2. So 1 over y minus 2 times dy over dx. That equals minus 3 all over 2x plus 1, x plus 2. And then we're going to do the integral of that with relationship to dx, and they cancel out quite nicely, and the integral of that relationship to dx. Fantastic. Okay, for the sake of speed, I'm just going to copy the answer here. So we do a partial fraction, and we're doing the integral of 1 over x plus 2. You would have to obviously work this out. Minus 2 over 2x plus 1 dx, and then this is 1 over y minus 2 in terms of dy. Fantastic. Okay, let's go next. So 1 over y minus 2, that becomes natural log modulus y minus 2. And that equals natural log x plus 2 minus, so natural log 2x plus 1. Now, when I do the derivative of this, it's going to be 1 over 2x plus 1 multiplied by the derivative inside is 2, which we got here, so nothing's on the front. That's fine there. So I'll keep that there. And we've got plus c, which I'm just going to write to myself time natural log of k. That's fine there. Okay, so we're going to divide these guys, and then we're going to multiply it by k. So natural log y minus 2 equals natural log, let's just make this really large, x plus 2 all over 2x plus 1 multiplied by k. Lovely there. So that means y minus 2 equals k x plus 2 all over 2x plus 1. Lovely. So y, let's have a thing. Can we add the 2? Yeah, we could anyway. Right, so we have to finish this, sorry. X is 1, y is 4. Fantastic. So 4 minus 2 is 2. X is 1. So 3k over 3. 6 equals 3k. Therefore, k is 2. And we're done. So the final answer is y equals 2. I'm bringing that 2 over, plus 3 lots of x plus, no, sorry, k was 2. Sorry, I got myself confused there. 2 lots of x plus 2 over 2x plus 1. And we can clean this up a bit. So y equals 2 plus 2x plus 4 over 2x plus 1. Cool. I see. 2 equals 2 plus 2x plus 1 over 2x plus 1 plus 3 over 2x plus 1. So that becomes 1. So your final answer, squeeze it in. 2 plus 1 is 3 plus 3 over 2x plus 1. And we're done. And we've got that all the way from there. Fantastic. Nice question. Okay. Test your understanding. Pause the video now and give it a go. And I will model it now. Cool. Right, so the first thing we do, you want to get y to one side and x is to one side. And we've got y is 2 and x is pi over 4. So times both sides by y. So y times dy over dx equals 3 over cos squared x. I'm gonna rewrite that as 3 times sec squared x. That feels good to me. Right, so now I'm going to do the integral of that with a relationship with dx, and they cancel out. And with dx there. Okay, cool. Let's clean this up a bit. So the integral of y in terms of dy, that equals, I'm going to bring the 3 on the outside, the integral of sec squared x in terms of dx. Right, the integral of y is just going to be a half y squared. That equals 3 multiplied, go to my formula booklet, sec squared x becomes tan x. So I'll take away the brackets, tan x plus c. Great, so we were told in the question y is 2 and x is pi over 4. So half times 2 squared, that is half of 4 is 2. And 3 tan of pi over 4. Pi over 4 is 45 degrees. So tan of 45 degrees is 1 plus c. So 2 equals 3 times 1 is 3 plus c. Therefore, c equals minus 1. And there we are. Final answer is half y squared equals 3 tan x minus 1. I think that's fine. Oh, it's just solving it. Yeah. Or equivalent in the mark scheme. So I guess we can do y squared equals 6 tan x minus 2. That's fine as well. Would I go as far as the square root it? I guess that's okay. Yep, fine. That's what I've got in the mark scheme. That's fine. That's fine. Fantastic. Yeah, cool. And there you are. Key points on derivative. I can't say the word. Equations. Get y on the left-hand side. That's what you saw me do every time by dividing, possibly factorizing first. We did that in the very first question when we factorized out. Oh, no, I've got other notes here. We factorized out here. Okay, back to the bottom. If after integrating you have natural log on the right hand side, make your constant of integration natural log. Okay, cool. Yeah. Combine all the natural logs together, so we can see here if that's what you've got. Combine them all together, so make that squared and then divide it by x. Fantastic. Sub in the boundary conditions to work out the constant. Better to do that sooner rather than later. And exam questions love partial fractions combined with differential equations. Cool, there you are. I've sent some questions for the person I'm making this for. And I'll put it on YouTube. Fun.